Hi everyone, my name is Shlomi and I manage the development team at Scylla. Thanks for joining my session about meeting your P99 goal while overcommitting another workload. So we're in the database space, but people are building applications. If they are successful, usually they'll reach a point in which they'll need to scale the database. If they're not successful, they won't have that issue, but then again, we shouldn't help them at that point. So scaling the database and looking at SaaS vendors and their recommendation, a lot of the vendors push users to the same solutions. So if you go to Azure and look at Postgres recommendation, you'll see that Azure actually recommends users to create a read replica if they need to run their BI workload parallel to their online workload. The same holds for MySQL. If you need to do some analytics over your MySQL data and you have an online workload, please create a read replica. That will segregate the two workloads and make sure your online workload is not affected by your analytics workload. Surprisingly, this also holds for NoSQL databases. If you go to Atlas, you'll see that if you want to run analytics, you are recommended to use a read replica. Create simply a replica and connect that to your BI connector. And believe it or not, if you're using DynamoDB, you'll get the exact same recommendation. If you're doing scans in parallel to regular gets, they are much heavier. So although in DynamoDB you can define very well what is the amount of read requests you'll send to the database, and all the limits that you can specify are very fine-grained. At the end of the day, if you want to say, I want scans to have 50% of the read throughput from the disk, and the online workload to have 50%, you are forced to create a read replica, or try to manage that externally. Somehow control how many gets you're doing towards the database versus how many scans you're doing and what is the cost of each. You can get that information from DynamoDB in the responses for your queries. But again, the off-the-shelf solution, if you want to segregate, is simply create a replica for scans. So scaling the database, the solutions that we know are, well, one, increase the database size. But that doesn't really sound like it solves the issue people have. If people applications are successful, they'll need to add analytics. They'll need to add additional workloads using the same data. They need a way to segregate and isolate those workloads on the same database. By increasing the database, you're actually allowing all the workloads to work on the same data. But you do not have a solution to segregate the different workloads. If you want to segregate the different workloads, analytics versus online workloads, you are recommended to use read replicas. And last, if they're successful, they will need to create database caches for their hot data. But for application developers and application deployers, this is a nightmare. Are they doomed to use complex application logic, to go to a database cache, see that data doesn't exist, and then go to the database, and then, or do complex invalidation of the data? Are they doomed to add additional replicas to isolate the workloads? Can't they simply specify a single pool of resources to be used for all their queries? Are they actually doomed to overpay and underuse? By providing different replicas and database caches, we're actually allowing different workloads to use different resources. But in doing that, the user has to pay for each resource and cannot use those resources shared across all workloads. A better solution from the customer endpoint would be to have a single pool of resources and use all of them for all its workloads. So workloads management. What usually we talk about workloads is we want to define for each workload the latency requirements and the side effects, the timeouts, after which a response that is returned is not really interesting. We want to define the throughput, how many requests per second that workload will have. And we want to define the type. The type has to do with if the workload is interactive, or some people call it open world, in the sense that it's an online workload where coming from users on the website or mobile devices. Or is it batch? Is it capped? Do we know how much requests per second in the maximum we will have? That has to do with how we will respond to overload cases. The next item we are actually looking to define is the priority between the different workloads. Again, if we had one shared pool of resources, we want to define the priorities between the different workloads to say that one workload has higher priority than others. And above all, we need visibility. At the end of the day, a lot of people segregate the workloads because they simply don't know. It's as simple as that. We have to know what's running on the database, what is causing the issue. Even if we have two different online workloads, we can have a bad query running in the system. We need to see that. Let's look at an example. This example has to do with an online application and an analytics application. The online application has a low latency requirement of 2 milliseconds and also specifies a timeout. The timeout means after a point in time after which it's not relevant, the response. It has also a throughput. On the other hand, the analytics is a batch, meaning that it's more capped, but it has a higher latency requirement. If we talked about the different workloads, we also set the priority. You're always told that everything is important, but when push comes to shove, product managers and product owners in every company will have to decide when there are issues. They will have to decide which workloads are more important. So they will have to decide if the online aspect of the business that has to do with customers is more important than the analytics or the reporting or the billing part. At the end of the day, if everything is important, then it means that everything needs its own resources, or they need a much bigger resource pool to be able to handle all the load. You have to specify the types, the latencies, the timeout, and the throughput. So it's complex. The key abilities that we're talking about is isolation. We have to, when we're talking about a shared resource, we have to assure that isolation between the different workloads is adhered. We cannot have a bad query running in the system eating up too much memory or too much CPU. So if we had correct isolation, we can have accounting and then do prioritization. But without isolation, and correct isolation has to do with all resources, we cannot have accounting and prioritization. And at the end of the day, a bad query, as we all know, can eat up too much memory or too much disk or CPU, or even a combination of them. So legacy databases that have been here from the Stone Ages. Oracle Quality of Service has a very nice dashboard. If you look, I'm not sure a lot of you are using it. I never used it. But looking at the documentation, you can see that Oracle does provide this ability So if you're using Oracle RAC, you can define different workloads. And for each workload, you can define a rank of priority and a latency, and also get a measurement of how well that latency is adhered. As on the performance satisfaction metric, you can see the green parts are the parts in which the latency was kept, and the red parts are part of time in which latency was not met. Oracle Quality of Service will also provide you recommendations about resource allocations that you can do. But please note that Oracle provides this ability based on allocating dedicated resources. So although it's a shared Oracle RAC pool and different workloads work on it, each workload is allocated dedicated resources. It's not the same CPUs that are used. And if the same CPUs are used in the server pool, for example, then you have an issue. If you want to make sure that it works, you need to decrease the number of workloads running or increase the number of assigned resources to that specific server pool. IBM DB2 that has been here from the Stone Age as well also has a workload manager. It has even finer grained capabilities than Oracle, based on my understanding. It has neat tricks about how to specify the different workloads and detect them. You can do that based on the connection or the actual table being accessed and so forth. On the other hand, it doesn't have such a sophisticated and nice view about your workloads and are you actually living up to the metrics. You can cap your workloads with respect to how many requests per second are sent for each workload. The sample here is a sample showing resource allocation for different workloads. So what is Scylla's approach to the issue? So Scylla's approach to the issue is doing fine-grained metering and providing real isolation for resources. And today we do that both for I/O and for CPU. The scheduling basics, if we're talking about CPU, is we have we are actually breaking up operations into small tasks. And each operation broken up is associated with a specific workload that has different shares or different priorities. The scheduler is supposed to both assure fairness, which means different workloads, all of them will execute. But in addition to that, it's also supposed to keep up with prioritization. It's very similar in some sense to the CPU scheduler, although it's cooperative scheduling. And let's look at two examples. If we have two different workloads using the exact same priority, 100 shares, you can see that it's interleaved. You have a blue task and a red task, and a blue task and a red task, and that would keep on going as long as there is enough tasks from both workloads. On the other hand, if you have two different workloads, in one 100 shares and the second one with 15 shares, then you'll see two different slices allocated for the blue and one slice allocated for the red. And again, as long as there is work for both workloads, this will be kept on and adhered. And how do we allow users to specify that? So we allow system administrators and users to specify it by creating service level. You can think about a service level as a workload. And service level are assigned to roles and users, allowing us ability to segregate inbound requests and associate them with a specific service level. You can specify the shares, the timeout, and the workload type. Here you have a slide actually showing the effect of using workload prioritization. and workload management in Scylla. We have here on the same system two different workloads running. The first graph in blue, the higher one with non-isolated 30 milliseconds, shows what happened when we have an analytics workload and an online workload running with the same priority, not being segregated. So everything is thrown at Scylla as one. All the queries have the same priority. And since it's non-isolated, there's no way to say that the online workload has higher priority. The end effect of that is the online workload has 30 millisecond P99 latency. The second graph in purple shows what happens when workload and service level are set to the system. And in that case, Scylla is able, based on scheduling, as we've seen before, to schedule queries coming from the online workload more frequently than the analytics, providing it more shares of CPU and execution, which ends up with better P99 latency. So workload management, and what is the state of the union? So I collected the information from different databases, and this is based on my understanding of the different capabilities, but in no way this is recommending a specific solutions. All databases, of course, have the benefits and cases in which they're best. SQL, you can do joins. NoSQL, you can have more data. And different databases have different characteristics, but this is related specifically to workload management. As you can see in the SQL space, there has been, which have been, of course, the databases have been here for a longer time, there has been more investment. So more boxes are checked, especially in Oracle and IBM DB2, that have paved the way for a lot of the features. Oracle visibility by far is the best in my view. On the NoSQL space, the amount of time that has been spent is lower. Some of it may be attributed to the fact that moving resources around is simpler nowadays. So if you're using Kubernetes, it may be simpler to say, I want to resize my workload and allow more cores for a specific workload, or assign more cores for a read replica, as an example. But having said that, it still is segregated and isolated resources. And in Scylla, we are allowing the same resources to run multiple workloads and still provide prioritization. So to sum up, no, we are not doomed. We can see that we still, in the NoSQL space, have a lot to learn from the SQL space. And a lot has been done, and we can take the knowledge and solutions that have been done there and implement them in the NoSQL space. It is very complex, and throwing more money at the problem is a solution, but it can take you to a certain level. Duplicating a petabyte data only for analytics is a waste of money. Scylla and others are working towards that, and it would be great if you provide us feedback if you think this is a worthwhile direction. Thanks for joining my session for meeting your P99 goals, and I hope you'll have a great summit.